Welcome to today's class. I want to talk about this question. The chapter is about the floating and sinking. Floating and sinking, they bring trouble a lot, but I shall simplify everything for you as for today. Now, the question today is a block of length 80 centimeters. So the length of the block is 80 centimeters. The cross sectional of the block is 3 square centimeters. The density 1300 is completely immersed in a liquid of density. So the keyword here is completely immersed. Completely immersed in a liquid of density 1030 kilograms per cubic meter. Determine the mass of the block. So one can easily determine, and the weight of the block in the liquid. Now, before I do the question, let me just introduce the chapter of floating. Chapter of floating and sinking. Now, in floating, we deal with the law of flotation. The law of flotation, while in sinking, this one we deal with the Archimedes principle. The Archimedes principle. Archimedes principle. Now, in floating, when an object is floating on the surface of water, or any given fluid, a fluid in this case can be either liquid or a gas. So when an object is floating, it displaces its own weight. So the weight of the fluid displaced is equivalent to the weight of the object. So here we have the weight of fluid is equivalent. This one must be equivalent to the weight. This the fluid displaced is equivalent to the weight of floating object. This one is in floating. Now, from the weight of the fluid, which is equivalent to the weight of the floating object, this one you can conclude that the mass of displaced fluid, is also equal to the mass of floating object. Floating object. Now that is about the floating, the law of flotation, which says that an object floating on the surface of a fluid displaces its own weight of fluid in which it floats. Now briefly, let me talk about the sinking. In the sinking, we deal with the Archimedes principle. This one we talk about the Archimedes principle. And the Archimedes principle, we have when an object is fully or partially immersed in a fluid, it displaces, it experiences an upthrust which is equal to the weight of the fluid displaced. In this case, we have the weight of fluid displaced. This is the same as the upthrust. Now, in simple terms, when you have the weight of the fluid displaced, when you place an object inside a fluid, the volume of this object, immersed in fluid. This is the same as the volume of fluid displaced. Now the difference is this. In floating, the weight of the fluid displaced is equivalent to the weight of the floating object. This is the difference. Floating, the weight of the fluid displaced is equal to the weight of the floating object. While in sinking, the volume of the object immersed in a fluid can be partially or fully immersed is equal to the volume of fluid displaced. So floating, we have the weight of the fluid displaced is equal to the weight of the object floating, while in sinking, the volume of the object immersed is the same as the volume of the displaced fluid. Now, let me go back to our question for today. We have a block of length 8 centimeters. Cross-section area of the block is 3 square centimeters, and the density of the block is 1,300 kilograms per cubic centimeter. Now determine the mass of the block. Let me start with question A. Question A, the mass of block. Now, how are we going to determine the mass of the block? How am I going to determine the mass of the block? Now, from the question, we have the length of the block and the area, the cross-sectional area of the block. Now, using the length and the area, I can get the volume of the block. After getting the volume of the block, because we have the density of the block, I can use the formula, density is equal to mass over volume, to get the mass of the block. Now, let me start. The volume of block. Volume of block, this is equivalent to the cross-sectional area. Cross-sectional area multiplied by the length. So this is equal to 80 centimeters times the cross-sectional area, which is 3 square centimeter. This gives you 240 cubic centimeter. So that is the volume of the block, 240 cubic centimeter. We have the density of the block. So the density is equal to 1,300 kilograms per cubic meter. I can easily change this one to be 1.3 grams per cubic centimeter. So I have the density. The density of the block is 1.3 grams per cubic centimeter, and the volume is 240 cubic centimeter. Now I can get the mass. The mass is equal to the density multiplied by volume. This is equivalent to, the density is 1.3 grams per cubic centimeter times the volume of the block, 240 centimeter cube. Now, that gives us the mass, which is 312. This is the same as 312 grams, which is equal to 0.312 kilograms. So this is the mass of the block. Part B, the weight of the block in the liquid. So the mass of the block here is 0.312 kilograms. Now let me go to part B very fast. I have the weight of the block. Now again we refer to the sinking, because the object sinking say that the volume of the object that is immersed in a fluid is equivalent to the volume of displaced fluid. I say now, part B, volume of displaced fluid is equivalent to the volume of block. This is equal to, volume of the block is 240 centimeters cube. Now that is the volume of the displaced fluid. So you have the volume of the displaced fluid, the density of the displaced fluid. Now we can get the mass of the displaced fluid. Now the density of displaced fluid, density is equal to 1030 kilograms per cubic meter, which is equivalent to 1.03 grams per cubic centimeter. Now using the density is equal to mass over volume. This implies that if density is equivalent to mass over volume, it implies that mass is volume times density. So mass is equal to volume times density. So this is the same as 240 centimeter cube times the density, which is 1.03 kilograms per cubic centimeter. This gives you, it gives you 247.2. So this is the same as 247.2 grams, which is equal to 0.2472 kilograms. Now, this is the mass of displaced liquid. Now, if we have the mass of the displaced liquid and we have the mass of the block, now you can find the apparent mass of the block. The apparent mass of block and this is the mass of block on the surface of the mass of the block when it is immersed in this liquid. So this is the same mass. The mass of block in air, 0.312 kilograms minus 0.2472 kilograms. So this gives you 0.0648 kilograms. So this is the apparent mass of the block, 0.0648 kilogram. Now I have the apparent mass. I can get the weight of the block. Apparent weight is the same as product of mass and gravity. This is equal to 0.0648 times gravity 10. And the answer is 0.648 newtons. So this is the weight of the block in liquid.